Alright, you're looking at a study guide right here. I'm just going to go through, I don't know, about a quarter to a half of the slides with you, just to get you started and give you an idea of what you're expected to do in these problems. So you're taking a road trip. You start the day off with a full tank of gas. Hopefully you're not driving because I don't think you have your license. But anyway, your tank holds 16 gallons of gas. On your trip you use 2 gallons per hour. Anytime you see this phrase right here, that's a good indication that it's going to be slope. Slope, of course, is change in y over change in x. You have two different variables here, gallons and hours. So there's a good indication right there that it's slope. Consider the relationship between time and hours and amount of gas remaining in the tank. Well, when you start out the trip, your 0 hours in your trip, there are 16 gallons of gas. After an hour, since you're losing 2 gallons per hour, does that mean your gas goes up or down? Well, you're losing gas, right? So we get 14 gallons, and that's going to keep happening throughout here. Now I'm listing 3 hours and 10 gallons. If I wanted to, I could be fancy here and say 5 hours, and of course with 5 hours times 2 gallons per hour would mean that you're losing 10 gallons of gas from the 16 you started with, so you'd have 6 left. I'm not going to be fancy, and I'm just going to leave this as 3 and 10. But just to show that that's an option. So the rate of change in this scenario, it would be, when they say rate of change, that's change in y over change in x. And you see I wrote down 2 over 1, and I think that's a popular answer. The one thing to watch out for is that you're losing 2 gallons of gas. So if you say just 2 over 1, that's really not correct. It would be negative 2 over 1. And I would even simplify this a step further and just call it negative 2. They ask right here, what does this mean in this situation? I would say 2 gallons of gas are lost each hour. Something to that effect. When they talk about the situation, you want to use the variables that are involved in the problem, gas and hours in this instance. So they asked on slide 3 at the bottom here to graph this relationship. So you can see 0 hours is x and 16 gallons is y. So I'm going to graph that point. So 0 for x is right here. 16 for y would be right about there. So that's a point. Another point would be 2 hours and 12 gallons. Actually, let me go back and we'll go in order here. 1 hour, 14 gallons, because this is pretty cool. So 1 hour and 14 gallons, that would be right here. And if you remember, our slope is negative 2. We're going down 2 and right 1. If you keep doing that, you'll hit that point, 2 hours and 12 gallons. And we could keep doing that for 3 hours and so on and so forth. And what you'll see, if we connect these dots here, and I just continue my line all the way straight down here, we get to a point where it says 8 hours and 0 gallons, meaning that if you keep burning 2 gallons per hour, after 8 hours, you're not going to have any gas left in the tank. You're going to need to stop for gas. So the y-intercept of the graph is 16. The y-intercept in the table is 16. It is where x equals 0, so it is 16. And then this last one, what does the y-intercept mean in this situation? I would say pretty much what it says right here. You start the day with a full tank of gas. So before you drive, there are 16 gallons in the tank. And that before you drive means you've been driving really for 0 hours. A linear equation, this might be new phrasing, but it really just means slope-intercept form. So in this case, we said the slope was negative 2. And we said the y-intercept was 16. So it'll just be negative 2x plus 16. Alright, I'm going to stop right there. Hopefully that's enough to kind of guide you through the next few slides.